Hello everyone, how are you all doing? I hope you all are good. So today here we are back with a new video on our structure series, and this video is going to be on truss. So how we will model the truss in Revit, that we will see today. So this is the structural template which I have opened, and for modeling the truss, where you can go is you can go here in this truss option, and once you enable this in the options bar, it asks you where is the placement plane. As of now, let this be on level 2, and what we will do, we will select the type of the truss. As of now, there is only one truss that I can see here, and let the length of the truss be 10 meters. And when I go in 3D, you see here that there is a truss which I have modeled, and all the elements of the truss are clashing with one another. So how can we avoid this clash? This is the first thing that I will cover up today. So if I go in front view, in 3D view, so you can see here that there are various elements which are clashing with one another. So to avoid those clash, what you can do is you can go into the contextual modify tab, and you can select the option of cope here. Once you select the cope, select the element that you want to cope with. I'll just do Control Z again, select the element that you want to cope with. See, this is how you can see here that this element is avoiding a clash with the vertical web. Okay, so here if I go into the edit type properties, you see here that there are vertical web, there are diagonal web, and then bottom as well as top chord. This is the top chord, this is the bottom chord, this is the vertical web, and this is the diagonal web. Okay, so as I have avoided the clash here, in a similar manner you can avoid the clash with all the other truss components. But still you see here that there is a gap. So how can you fill this gap here? You can select this element, and now you see here that there is a coping distance. So keep this coping distance as 0, and here you can see that it is touching this element without clashing. Okay, this is one thing. Second is, what if you want to change the profile of this truss? When I say profile of the truss, as of now this is a rectangular one, okay, a whole truss. In order to change the profile, what you can do is you can select the truss, and then you can go to this edit profile. And once you go to the edit profile, you can delete this top chord, and then you can select this component here, and now you can give an arch. And once you click here, you see here that this is how we can transform the shape or the profile of the truss. Still there is a clash that you can avoid. You can directly go to cope here, and then select the part of the truss that you want to cope with. Just because there is a coping distance that we have removed, because of which it gives you the error. If we try with the other element, see here, if you try with the other element, it will be unable. Okay, so this is how you can avoid the clashes with the components. And I'll just press Ctrl Z. I'll just go back. Let me just go back here. Okay, so there are some settings that you see here in the truss that I want to take you through. So first one is the top chord. Okay, so if you don't want to see the top chord, then you have the option wherein you can select this, and the top chord will disappear. Okay, the top chord will disappear, the truss will be without top chord. In a similar manner, what you can do is you can disable the top chord. And now there is a rotation angle. If I go in 3D view, this is at 0 degree. But what if you want to rotate this truss in this manner? What if you want to rotate this truss in this manner to this side here? So in that case, you can enter the degree here, and your truss will rest it. Okay, and then there is rotate chord with the truss. For example, now even the chords are rotating with the truss, but if you uncheck this option, what will happen? The chords will be at 90 degree, and it will not be rotating with the truss. Okay, this is one thing. Second is there is this vertical justification. For explaining that, let me go in the south view. All right, and what will I do is I'll bring this truss down. I'll bring this down. Okay, now let me just move this truss down here. All right, okay. So here, okay, let me bring this down a bit more. All right, so we have moved the truss which is aligning with the level 2. Consider that there becomes a need for me to give the offset from this particular level. In that case, what I can do is I can change the vertical justification. I can say that justification, let this be from the bottom, or justification, let this be from the top. So what you have seen here, there is an offset that Revit has created. Okay, this is one thing that I can do. And then this is stick symbol location. As you have seen, I have demonstrated this for framing. So for doing this, you need to make sure that you are in course view, and then in course view you can play with this defining the bearing chord. Okay, as of now the bearing chord, we have set this at the bottom because this is the chord of the truss which is bearing all the load. Okay, and then there is non-bearing offset. For demonstrating non-bearing offset, what we will do is we will go here in 3D view, and consider that there is a roof that is coming in. What will I do is I'll just draw a roof here, or else a structural floor. And for modeling the structural floor, let this be the profile. And what I will do is I am trying to align here. I am trying to align this edge over here. All right, and let me take this over here. Okay, so when I go in west view, okay, let me just move this bit up onto this truss. And now, okay, so as I have moved this truss here, you can see here that there is a cantilever that this uh slab is creating. Okay, or else you can say a bearing of 600 that the slab is creating. So now if you want this truss to support this floor here, okay, or the slab here, at that time what you can do is you can select the non-bearing offset. So when you keep this to 600, what will happen, your truss will be changing its positioning, and this is the non-bearing offset. Okay, so here this is the original place for the truss, but now as you have set the non-bearing offset to 300, this is how your truss will be supporting your slab. Okay, this is the non-bearing offset. And then apart from that, rest other options I have covered. Here you can see here that this is the panel width. As of now this is 1500, but if you set this to 2000, see what will happen here. See, let me just go to front view, and we'll change this to 3000 so that we are able to spot. See, this is how these distances from chords, this is how the distance from the chords will change, will orient. Okay, so you need to make sure that this is the distance that you have kept it at the initial stage when you were modeling the family. Okay, this is one thing. Second is, again I will set this to course. And when I set this to course, you see here that this is the diagonal web and this is the vertical web, and there is a spacing here. Okay, so if you want to close this spacing, what you can do is you can disable this option, and once you do that, what will happen, it will fill that symbolic cut that it was showing. Okay, this is one thing. And second is web orientation. Okay, so if you want to orient the web of this truss, you can do that, and that orientation can be with respect to vertical web or diagonal web. Okay, so this is that option. which lets you do that. Apart from that, consider that consider that you want to have some changes in this truss profile. Okay, again, when I say truss profile, it means that you want to change how this vertical as well as diagonal webs are meeting. In that case, what you can do is you can go to edit family, and once you go to edit family, what we will do here is we will keep only two views active, okay, to have a better understanding. And this is the family environment of truss. So in this family environment of truss, what you can see here is you can see only the 2D lines, and these 2D lines demonstrate whether it is a top chord or whether it is a bottom chord or whether it is a web. Okay, so now you cannot see any dimensions here. For enabling the dimensions, I have enabled this visibility graphics window, and from here I will say enable everything. Okay, so when you see here, there are so many reference planes here and there, and then there are so many dimensions. I will delete everything. When I delete everything, what happens is nothing. Okay, there's nothing. There are just reference plane. And now we will model the truss right from the scratch. For doing that, what you can do is you can tell Revit that this is your bottom chord, and the bottom chord is indicated by a pink line. I have pressed AL, which is the shortcut for align, and I am locking my truss here. This is how I am locking. And now I will lock this top chord at the top reference plane. Okay, when I select this, it says top chord. Yes, that is fine. Okay, now what will I do? I will go to create, and then I will align bottom chord. Okay, so I will again press AL, and I will align this over here, and then this over here. After that, this to this one. Okay, and now I'll just model one vertical web. I'll come here and I will say this is my vertical web, and I am aligning this to the top reference plane and this one to the bottom reference plane, and then this I will align it here. Okay, now you must be wondering, as this is just a 2D line, so how Revit will understand which structural framing it has to assign to this. So when you select this, or when you come here in this family types, so you can assign respective family type to this one. As of now, there's only one family in this one, which says UB305. Okay, this is the structural framing that is assigned to this top chord. Okay, so now when you load this into the project, what happens? See, suddenly the profile or the entire truss is changed. Okay, so what we will do, we will model this again so that it should look different from the initial truss that we loaded. Okay, so what we will do, we will have some reference plane, and these reference plane I will simply align this here. I'll drag this down here, or else let me model this reference plane again. Okay, I will keep it here, and then no need to lock it because it's already locked, and I'll move this here. Okay, I'll move this here, and in a similar manner I'll copy this and I'll place at least some reference plane. Okay, so here these reference plane I want to align this equally, so I have pressed DI for doing that, and now when I finish this I will select this command. Okay, this is equal constraint, and now what will I do? I will model the web here. Okay, to model the web I have selected that option, and then here let's us align this to this one, but it says no need to align because again there is a reference plane which is locked to this one. Okay, so what we will do, we will simply align our vertical web to this one and we will lock it. Okay, and we will lock it in a similar manner. What we will do, we will copy this web here. Okay, and I will press again AL. I will make sure that this is locked to this one. This is locked to this one, and see what will happen. Once I load this, this is how your truss will be seen. Next is we will place the diagonal webs here, and for placing the diagonal webs, what will I do? I will go to web again, and then I will start from this point. I will stop it here. This is how I will go on. Okay, just make sure that it is snapping this point, and then you stop it here. After that, over here, and now see what will happen. Once we load this into the project, here you will find there are diagonal webs. Okay, but this bottom chord has to be stopped here. So you will again go to your family environment, and here what you will do, you will press AL, make sure that there is a reference plane that you're selecting, and then press tab. After that, you say remove constraint and then lock it here. So once you load this into the project, this is how your truss will look like. Okay, so these things we have done on this particular end. So what we will do first, we will copy all the reference plane from here. I am going into filter, I selected reference plane, and then I will say draw mirror. So once after mirroring, every element has come here. What you do, you select this dimension lines, and then you select edit witness, select this one as well as this one, and then say equal. Okay, so you have given equal constraint. After that, what you will do here is you will model these vertical webs also. Make sure that you are mirroring this one, and then simply copy this over here and align it. Okay, so just make sure that it is locked to those respective reference planes, and once it is done, just have a cross check. Just have a cross check whether everything is fine or not. You load this into the project, and you see here that everything is fine. So we'll try to have a little shortcut today. What we will do, we will copy all these diagonal webs, and then I will also mirror this onto this one. Okay, once I do mirroring, what will I see here? What will I see here? That it is perfectly following the reference planes. And now I will press AL. I will align this bottom chord to this reference plane. I will remove the constraint and see. So this is how we have transformed our whole truss into this one. And again, the entire thing will remain same. There are so many clashes that you can see. So you can go into the contextual tab. You can simply select the cope option, and you can cope all these elements. You can bring this somewhat closer over here for the demonstration purpose. Let me keep this here. So this is how you can work with the truss. I have covered all the necessary options, and if still you have any doubts, let me know. Okay, drop a comment, and yes, learners, as always, let us rise and shine together. Thank you.